Welcome to Data Engineering with Databricks. This is Ganesh. In this video, we are going to see how to download a JSON data from REST API. Before we get into the API concept, let me demonstrate how to convert a JSON string to a data frame. So here you see a simple JSON string. I'm assigning to a variable, then displaying the type of the variable. It's a string. Even though the contents of the string look like a JSON data, but it is not a JSON. It is JSON-like data, but behind the scenes, it is actually a string. So now what we're going to do is convert the string to a data frame. So before that, let's do an SC, like a Spark context dot parallelize a string that converts it into a RDD. Then I'm going to use that RDD here and convert it into a JSON data frame. So now we have JSON, we have a data frame which is reading the JSON data via RDD. Okay, so I have this display which displays the data. Perfect. Just to show you one more example quickly. Here I have an array of values. So again, a string which has a square parenthesis, which makes it an JSON array, multiple values, same concept. Here you go. You have multiple rows here. The reason is when you download the data from the API, you'll always get an array of data. So this will help you to remember the concept. Okay. So now I have the standard imports which I need for JSON and for API calls. The request I need to get the data from the remote server, JSON to convert all the JSON operations. Apart from that, I need the functions, types. These are the standard stuff. Perfect. So now let me go to this API call. So this is the government website which gives me all the make and model of different vehicles. So this is a API call which gives me a JSON output of all the makes. So I click this, it shows me 10,426 records. And again, I just loaded it like a minute back. And if this is hard to read, you can copy the data and paste it into JSON formatter. It kind of formats into a pretty looking JSON where you can find out like you have an object called account or a key called account, message, search criteria, and another key called results. This is a type of array because you have square parentheses. This is an array type and you have all these key value pairs, make ID and make name. So now I'm going to use this API call to download the data and convert this string into a data frame. Okay. So for that, I'm using request.get, the API call. That result is stored into a response object. So this is a live data. So there's always changes happening on the API side. You may see a record more, but more or less you should get the same number of records. So just looking at the type, it says it's a response model. It's perfect, but I'm interested in the text data. So I said response.text. It shows me a string. Perfect. I'm going to print the actual data. It's 10,426. Good. It didn't change in the last few minutes. So this is the data set I have, which I'm going to process. Again, my interest is not the count, not the message, not the search. I'm interested in this results key value. Okay. So what do we do for the results? First thing I need to make that string into a data frame. Okay. Like we did with the racial grade example, I'm converting this into a data frame. Taking the number of rows I have, it shows 1, that is perfect. And if you want to see like Y1, because you have one record with the count, message, and the results. Okay. So what did we discuss? I want the value of this particular column. It is an array of values. So I want to expand this array into multiple rows. So instead of just keeping it into one row, I want to expand it into multiple rows. So to do that, we have this particular explode function. So out of this data frame, I will select explore the results column, explore the column into multiple rows, which is giving a column alias name as lowercase results, then displaying the data frame. So what happens? It explores the column into multiple values, into multiple rows. And each row is an object. It's a dictionary by itself. I have make ID and make name. Make ID, make name. Similarly, I have around 10,000 plus rows. Now, what's the next step? We need to expand this make ID and make name into individual columns. Okay, but before that, let me find the count 10,426. That's the value we saw here, 10,426. So the value remains the same. That is perfect. Now I'm going to use the dot star notation. I'm going to expand the dictionary object into individual columns. So when I say make df3, make this column into make ID and make name. Is it clear so far? So I download the JSON into a response object. Then I have the response.text. I am passing that into a RDD, making it into a data frame. Then just doing a count, displaying the data frame, expanding, exploring the array values into multiple rows. Then using the dot notation, whatever is the dictionary object, I'm making them into individual columns. So this is the step one. Okay, then what's after this? Since you have a data frame now, I can always create a view out of it. So this way I can take a look at it and as a view. If you're like a SQL buff, you can say like select start from view name, then I can view see the data. I can view, again from a view, you can create a table and the whole nine yards, right? But let's not stop here. We have one more step here. The next step is the same API gives me additional information like for a given make, give me all the models. That'd be interesting to see, right? So they have next API call where I need to pass the get models for make, that's the endpoint, and you need to pass the make name format of JSON. So when I do this for the model outing, it shows me the make name, model ID, and model name. Again, this is a similar result. Count equals 49, message equal to this, search criteria, make Audi, get all the results, right? So let's try and implement this also. So this way we have proper data set which has all the make, and for every make we have a model. Okay. So where am I? Okay. So how do we do this? So the way to do that is I'm going to create a Python function. The idea is for every make, I need to get the model. So instead of writing it inside or using a loop, the best option is I'm going to use a function. The function takes the make as a parameter, then passes the parameter here, gets the data, the response object, and then returns me as a JSON object. Right? So JSON.load gives me JSON object. So this is the objective of this function. This function is a Python function. Okay. What I need after this? I need to setting up my schema. So let me first execute this Python function. So I'll create a hash function. And what is this schema? So if we look at this one, this gives me a count, it gives me message, and it gives me search criteria, it gives me make, and then I have the results. I have the make ID, make name, model ID, model name. So it gives you so much of information. But I don't need everything because I already have the make ID, I already have the make name from a different API call. So I don't need everything. At the same time, I don't need a count, I don't need the message, I don't need the search criteria. I'm kind of like want to limit the number of data I'm getting from an API. So for that, I'm defining a schema and I'm mentioning like, hey, for this struct type, which is an array, and the name key is results. For that results, I need the make name, model ID, and model name. Don't throw me everything. Just give me these three particular keys. So instead of giving me everything, just give me this last keys. If you want everything, you can mention everything. Otherwise, you can be limited to what you're looking for. Okay. Then next step is, let me run this. Okay. The next step is you have to register the Python function with Spark. Why? Because this function is a Python function and it runs on the driver mode. Spark being a distributed architecture, you want the data frame to be accessed from all the worker nodes. So this way, the things can happen efficiently. We just don't want the driver to do the job. We want all the worker nodes and everything to be happen in a distributed fashion. To do that, I'm registering my function get models along with the schema I'm looking for using a function called UDF. So this one registers this function as a Spark function. So now the new function name is UDF get all models. This is a Spark type function based upon the actual Python function and this particular schema. Okay, I'm registering it here. Just to confirm the function type, it is type, it says it's a function. So I know it is registered as a function. Okay. So now I know as an example, I have a Jaguar. If you want Audi, I can say like, I just want to be nice to the API provider. So I'm just limiting the filter to one make. If you don't want to limit to one, if you are looking for everything, then you don't need to use this filter. It's going to give you everything back. So for now, I'm just saying like creating a data frame and filtering out only one data. Okay, so I got this. I'm displaying the make, which shows this is the make ID and this is the make name Audi. Okay, so now I'm creating another data frame where I'm calling this function. So make model df1 equals this make 3, this function data frame here with column. I'm creating a new column called result and as invoking this function and passing the make name. So if I have all the records, so this is going to get executed for every record. You have like 10,200 records, then it's going to get executed 10,200 times. Right now I have only one record here in my data frame. This is going to get executed only once. So it calls this function. This function literally calls the get models, which is available here based on this particular schema. So it passes the make name, that's Audi, gets the data. Then I'm renaming the make name to make ID, make underscore ID to make ID, make underscore name to make name. This is just to demonstrate. You can also change the column name. Okay, that's done. I'm displaying it. Now it shows me all the data sets that I'm looking for. So make ID. Now I have this again. This is a values set of values here. See this one? Square parenthesis. This means it's an array of values. Now what do we do? Array has to be exploded. Then all the objects has to be using the dot notation. We have to make it into multiple columns. So print schema, prints a schema for me. Okay. Now I'm going to say explode it and giving model results as a alias name. So make name. This is all the different models. Okay, just doing a count. So make sure how much I get back. 49. You see the values here is 49. So it's a perfect data. Then I'm doing a dot notation, dot star notation. It expands the data into a model. Then another data frame with all the renamed columns. And the final data frame, it gives me the make name, model ID, model name. Now we have this one. If you're interested, you can further deep dive into like more API calls, or you can store this into a data table, or you can do whatever you have to do. But this is the idea to get the data from an API. I hope this helped you and see you in the next video. Thank you.